Hello, ladies and gentlemen. Welcome back. We are on chapter 6.4, Use Inverse Functions. Now, we're going to be doing some graphing. Hopefully you have graph paper at home. If you don't, then as best you can, draw your graphs freehand. Hopefully maybe use a straight edge so that you can be as accurate as possible. All right, here we go. We'll talk about the graphs here after we look at a relation and what the inverse relation looks like. Okay, here we go. So I'm going to go ahead and put some ordered pairs over here. So we're going to go ahead and go with 2, 4, 3, -6, 0, 5. And again, if I go too fast, ladies and gentlemen, hit the pause button, catch up, and then continue. And then 1, 7. Now, the inverse relation, super easy, ladies and gentlemen. The inverse relation, all we do is flip the x and y. So 4, 2, -6, 3, 5, 0, 7, 1. Okay, now we're going to graph it. We're going to graph both relations. Now, you'll notice in this graph, we've got a diagonal line going from the lower left to the upper right. Okay, well, that's a linear line, and in fact, that is the line y equals x. The slope is 1, and the y-intercept is 0, okay? That is our reflection line for inverse functions, for inverse relations. All right, so let me go ahead and plot the blue ones first, all right? So 2, 4, so over 2, up 4. That dot will go right there. Okay, 3, -6, over 3, down 6. That dot will go right there. Okay, 0, 5, over 0, up 5. That dot will go right there. And 1, 7, over 1, up 7. That dot will go right there. Okay, now, the inverse of 2, 4 is 4, 2. So that means over 4, up 2. 4, 1, 2. Now, look at that, ladies and gentlemen. Look at the dot 2, 4, and look at the dot 4, 2. That is a reflection over that dashed line. Okay, let's go to the next one. -6, 3. So left 6, up 3. Cool. Okay, now look at 3, -6, way down in the bottom. That's a reflection over that dashed line. Okay, now 5, 0, over 5. 1, 2, 3, 4, 5. 5 zeros right there. You will notice, ladies and gentlemen, that that is a reflection with the 0, 5. And then the 7, 1, over 7, up 1. That's right there. All right, pretty cool, huh? Pretty easy. All right, now let's move on to having equations, all right, functions. So here we have f of x plus 2. Okay, first we're going to go ahead and graph this function, and then we will do the inverse, and then we're going to actually rearrange the equation to find the inverse function. All right, so I'm going to graph this. Remember how we graph this, ladies and gentlemen? We start at 2 on the y-axis. Okay, now I'm going to put that dot down, so that is 0, 2. Now, the slope says up 4 over 1. So I'm going to go up 4. 1, 2, 3, 4 over 1. Okay, now that ordered pair, ladies and gentlemen, is 1. Let's see. 1, 2, 3, 4, 5, 6, 7. I think I went up too many here. Hold on, ladies and gentlemen. Let me do that again. Up 4 over 1. So let's see. 1, 2, 3, 4. Okay, I think I was up a little too high. Up 4 over 1. Okay, now that ordered pair is 1, and then 1, 2, 3, 4, 5, 6. Okay, now I'm going to go ahead and I want more dots, folks. Okay, so I'm going to go ahead and go up 4 again and over 1. So that dot's going to be right there. That's 210. But I'm going to also go backwards. Okay, I'm going to go down 4, 1, 2, 3, 4, and over 1. So I'm going to put that dot right there. That's -1, -2. All right, I'm going to go down 4 again. 1, 2, 3, 4 over 1. That's -2. 1, 2, 3, 4, 5, -6. And I could go one more time. 1, 2, 3, 4. Okay, right there. So that looks like it's -3, -10. Now, the inverse, ladies and gentlemen, well, that's going to be 2, 0, 6, 1, 10, 2, -2, -1, -6, -2, and -10, -3. All right, let me put those dots. Well, let me draw a line through this first. Okay, so here is our linear line for that function. And now I'm going to go ahead and do the other ones in green. So 2, 0, and then 6, 1, and then 10, 2. Okay, now the other way. Oops, I didn't go down far enough on that one. Whoops. Hold on here. How do I get rid of that picture? There we go. Sorry about that, folks. All right, my picture's in the way here on my controls. There we go. And there's the linear line for that. Okay, now let's come up with the equation, the inverse function. So let me rewrite this right here. F of x equals 4x plus 2. All right, folks, I'm going to rewrite that y equals 4x plus 2. So what we're going to do is we're going to switch x and y. So we're going to write x equals 4y plus 2. We switch x and y. Okay, now we're going to solve for y. We're going to get the y by itself. Okay, well, ladies and gentlemen, I'm a little strange at times. I'm going to go ahead and rewrite it. I'm going to flip-flop right now because I always like to have the y on the left side when I solve. All right, so we're going to subtract 2. And then we're going to divide by 4. So the inverse, ladies and gentlemen, is y equals, that's 1/4 x minus, and 2 over 4 can be reduced to a half. But when we write that, we put f with a -1 there, ladies and gentlemen. That means it's the inverse. That -1 means it's the inverse. Okay, so the inverse function that gives us, let me do this. Okay, that inverse function, 1/4 x minus a half, that, if we graph that line, that's the green line we put right there. And you can see the y-intercept is a -1/2. Okay, let's do another one, folks. If you got to rewatch that, rewind and rewatch that. But let's do another one. We're going to do several of these. Okay, so on this one, I'm going to go ahead. I'm going to graph first. So I'm going to start at 2. And the slope says down 1 over 4. Okay, that's all I can do going that direction. Now I'm going to go backwards. Okay, so I started at 2 and then I used my slope. So I'm going to go ahead and write these ordered pairs. So 0, 2. Then we've got 4, 1. Then we've got 8, 0. Okay, what else do we have? We have -1, 2, 3, 4, -4, 3. And we have -8, 1, 2, 3, 4, -8, 4. Okay, hopefully I counted everything correct there. Now, the inverse is going to be 2, 0, 1, 4, 0, 8, 3, -4, and 4, negative 8. Okay, I'm going to go ahead and graph those. Okay, 2, 0, 1, 4, 0, 8, 3, negative 4, and 4, negative 8. All right, there is the line. And again, look at how it's reflecting. It's reflecting over, if I folded it in half, it reflects over that line. Okay, now we're going to go ahead and rewrite it and figure out what is that equation. All right, here we go. So I'm going to take and rewrite y equals negative 1/4 x plus 2. Okay, we're going to switch x and y. Okay, now I'm going to rewrite it so the y is on the left side. And then I'm going to solve for y. Okay, I'm going to take away 2. Hold on. That's a y. And then I'm going to multiply by negative 4. Okay, and so here that crosses off and we're left with y equals, now remember 4 gets multiplied to everything, negative 4 gets multiplied to everything there. So negative 4x plus 8. And so the inverse with the negative 1, the inverse of that function equals negative 4x plus 8. All right, and now we can see it. So the y-intercept is 8, you bet, there it is. And then it's down 4 over 1, down 4 over 1, down 4 over 1. Okay, so that is the inverse of the original function. Sorry, I kind of messed up the colors there. All right, rewind, watch that if you need to. Let's keep going here. So not everything's going to be linear, ladies and gentlemen. Let's take a look at this. So here we've got x squared plus 2. Wow, okay, x squared plus 2. Well, ladies and gentlemen, let's see here. Let's go ahead and put this into our calculator. X squared plus 2. So x squared plus 2. Now I'm going to go to the table. Well, I could graph. Let's see what the graph looks like. Oh, it's a parabola. Okay, so let's go to the table and let's see what we can do. So I'm only going to do the ones that fit. Negative 2, 6, negative 1, 3, 0, 2, 1, 3, 2, 6. All right, let's fill those in. So negative 2, 6, negative 1, 3, 0, 2, 1, 3, and 2, 6. Okay, so again, I just got those ordered pairs looking at my table, and I didn't want anything bigger than 10 or less than negative 10. Okay, so that's what fits. So let's graph that. So negative 2, 6, that will be right here. Negative 1, 3, that'll be right here. 0, 2, 1, 3, right there, and 2, 6. Be right there. All right, so there's our parabola. Now, that is a function, folks. That is a function. All right, now I'm going to go ahead and reverse those. 6, negative 2, 3, negative 1, 2, 0, 3, 1, 6, 2. Okay, I'm going to graph that. Over 6, down 2. Over 3, down 1. 2, 0. 3, 1. 6.2. Cool. Now, is the inverse a function? Remember the vertical line test? Okay, if you take a vertical line, okay, so if you draw, I'm just going to draw a vertical line quick. If I drew a vertical line, that's not very straight, is it? Okay, if I draw a vertical line anywhere on there, it touches in more than one spot. So therefore, ladies and gentlemen, the inverse is not a function. Okay, the inverse is not a function. Okay, let's keep going here. Next, but let's figure out what does the inverse equation look like, even though it's not a function. Okay, here we go. So again, I'm going to rewrite this: y equals x squared plus 2. Switch x and y, so x equals y squared plus 2. Okay, I'm going to rewrite that: y squared plus 2 equals x. All right, I'm going to get y by itself, everybody. Subtract 2. So, whoops, I want purple. So y squared equals x minus 2. Then we do the square root. And ladies and gentlemen, when you do the square root, you put the positive and negative in front. So the inverse is y equals positive negative square roots of x minus 2. And when I put that function notation in there, I write f to the negative 1. That's the inverse, equals plus or minus the square root of x minus 2. All right. Okay, let me go back so you can see the whole thing. There it is. Again, we can see with using the vertical line test that that is definitely not a function. All right, I think I've got a little bit more. Let's keep going. If you need to pause and take a break, now would be a great time to do it, and then come back and finish up. Otherwise, let's keep right on going, folks. How do you verify that functions are inverses of each other? Okay, to verify if they are inverses of each other, ladies and gentlemen, we're simply going to plug one function into the other. All right, here we go. So it doesn't matter which one you do. So what I'm going to do, ladies and gentlemen, is I'm going to take the 4x plus 2 and I'm going to plug it in to the x. All right. So I'm going to go ahead and let me write this out first. If f of g of x equals x, and g of f of x equals x, then they are inverses of each other. Okay, so I'm going to plug, first I'm going to plug the 4x into the other one. All right, here we go, folks. So I'm going to take and plug in the 4x plus 2 into the g of x. So I've got 1/4 times 4x plus 2 minus 1/2. Distribute. That would be 1/4 times 4 is 1, so that's x. And then 1/4 plus 2, that is 1/2, minus 1/2. Well, 1/2 minus 1/2, that is x. Hey, check. All right, now I'm going to do the other one. I'm going to plug the 1/4 x minus 2 into f of x. So I'm going to go ahead and, oops, that's minus 1/2. let me fix that. 1/4 x minus a half. So 4 times 1/4 x minus a half, close it, and then plus 2. All right, distribute. 4 times 1/4 x is x. 4 times a negative half is minus 2. And then we've got the plus 2 sticking out the back. And therefore we get x. Check. All right. If you didn't get that, rewatch it because I'm only doing one example of that, folks. Again, we plugged one function into the other. We got x. Then we did the opposite. We plugged in the other function into the other one, and we ended up with x. If they are equal to x, then they are inverses of each other. Okay, that means they will reflect over that y equals x line. Okay, last, here we go. Now, we have a small company that produces greeting cards. The cost C in dollars of producing n greeting cards per month can be modeled by this function. Find the inverse model. Now, folks, before we go any further, when we do word problems, we're simply going to solve for the other variable for its inverse. And there's a reason why that I'll talk about at the end. Okay, so when we do a word problem, don't switch the letters. Okay, again, when it's a word problem, don't switch the letters. So we've got C equals 360 plus 0.60 n. So what we want to do, folks, is we want to solve for n in this case. We want to solve for the other variable. All right, well, I'm going to rewrite this as 0.60 n plus 360 equals C. Okay, here we go. I'm going to subtract 360. So now I have 0.60 n equals C minus 360. Now I'm going to divide by the 0.60. Okay, that cancels out. And so what I have now, ladies and gentlemen, is I have n equals, okay, I'm going to split this up. 60 divided, or C divided by 0.60 minus, let's see, 360 divided by 0.60. I'm going to actually do that, folks. I'm going to take 360 and divide it by the decimal, and I get 600. That's a lot nicer. Okay, so this is what I'm going to consider my inverse, ladies and gentlemen. I just solved for the other variable in a word problem. Now, use the inverse function to find the number of greeting cards produced in a month in which the company's total sales to produce the cards was 615. So the number of cards produced is going to be 615 divided by the 60 cents minus the 600. And let's see, if we take the 615 divided by the 60 cents and then minus 600, 425 greeting cards. That's how many there are. That's how many were produced. Okay. All right, again, when we're doing a word problem, don't switch the letters, just solve for the other variable. That's going to be considered your inverse so that we can easily answer a question that's asking about how many greeting cards do you have when you're told how much money was made. Okay, and last, again, notice that we do not switch the variables. We did not switch the variables in finding the inverse model of that problem? If we did, that would be confusing because the letters are chosen to remind you of the real life quantities that are present. Okay, it would not make sense to switch the C because the C stood for cost and N stood for the number of greeting cards. If you switch those, then it gets all confusing because then your N is the cost and your C is the number of greeting cards, and that's just too confusing. So we just switch them and then solve for the other variable. All right, ladies and gentlemen, that is it. Good luck.